Okay, another little clip, basically to explain what happens inside a gas turbine. So, take this turbo prop. Okay, flow is in that direction through the propeller. Gas generator here. So the gas generator provides power to the power turbine, the free turbine. The free turbine provides the power for the propeller. The propeller converts the free turbine power into useful thrust power. Okay, so the efficiency is the useful thrust power divided by the power applied to the propulsive device. So that's the gas generator unit, which is a compressor powered by a turbine. Fuel is burnt, so that's where the energy is put in, and over here is where the energy is transferred to the propulsive system, the propeller. The gas turbine is just a means of generating the shaft power for the propeller. The turbojet, this thing, this is the gas generator unit. Very similar gas generator, but basically the same gas generator as what's on the propeller down there. The only difference is that this nozzle at the back end replaces the free turbine. Okay, the nozzle here accelerates low kinetic energy gas at the nozzle inlet to a high exit kinetic energy. So this produces a change of kinetic energy. The free turbine, in the case of the turbo prop, produces output shaft power. This produces output kinetic energy. Okay, that's really the reason why this thing is far less efficient compared to the turbo shaft. But gas generator and the output device here, we produce output kinetic energy. The core component is the gas generator. All gas generator systems on all gas turbines are basically the same, whether it's a gigantic turbofan or a little turbojet. They are all basically the same. So here I've got a knackered turbojet. Take the nozzle off, don't want that. So this is now the gas generator. Okay, this is the inlet side, and then the turbine outlet is down here. So turbine at the back end powers the compressor. What the gas generator does, this is the exit of the gas generator. What the gas generator does is supply a source of high enthalpy, high temperature, high pressure gas for the downstream device, be it a power turbine or a nozzle. So this is the gas generator unit. Now the high pressure is generated by the compressor. The compressor requires power. The power for that compressor is delivered by a turbine. Now that turbine doesn't get its energy from nowhere, so there's the combustion chamber in the middle. So I can strip this thing down. This is the compressor, turbines at the back, combustion chamber in between. Take the thing apart. It's a centrifugal compressor, so take the shroud off it. Simple device. Only one moving part. The compressor impeller is one half of the one moving part, so the impeller rotates in that sense. Impeller, diffuser. Take away the diffuser. Take the impeller off. And unfortunately it's sticking to its shaft a bit. Well, I suppose it's been sitting there too long. Let's try and get it out. Well, I can't get it out without... That's it. Got the case off at least. And you can see I'm struggling a bit with it. Oh well, never mind. Diffuser, combustion chamber, turbine wheel at the back end. You can almost regard a turbine as a reversed compressor. So there's the impeller at the front, and there's the turbine unit at the back. Rotates. If I can show you that. Okay, you can see the turbine rotating. I'm managing to rotate the turbine by turning the compressor. Okay, so the turbine and the compressor sit on a common shaft. Okay, one moving part. The thing that clanged down onto the ground was part of the turbine. That doesn't matter. One moving part. The complexity of the design is to get the compressor to work efficiently, to get the combustion system to work efficiently, to get the turbine to work efficiently. These are aerothermodynamic processes essentially. Okay, so a gas turbine consists of any gas turbine consists of a compressor driven by a turbine with a combustion chamber. The more complex gas turbines might have multiple shafts, multiple compressors, multiple turbines, but they're all basically the same. Only a very small number of moving parts, which is what makes them so reliable. Okay, so I hope that's helped in spite of my confusion there with taking this thing apart. That's all for now, thank you.